and I really appreciate you folks joining on time. I see 7 people already here. All right, we are live on LinkedIn as well. Okay, Rishabh, Rishi, shall we begin? We are live. Yeah, awesome. Hi, everybody. My name is Rashmi, and welcome to this panel discussion brought to you by Recro. I would love to know where you guys are tuning in from. So just, mention the name of your cities in the chat. And if you can also talk about which company do you work for and what's your experience. Would love to hear that from you. Welcome to the panel discussion again. Super excited to host this with Rishabh and Rishi, who have wealth of experience. And today we would be talking about microservice architecture, even if you're starting new or, if you already have experience in this space, I'm pretty sure you would have something to take away from today's session. So welcome again. Would love to again know where you guys are tuning in from. And thank you so much, Rishabh and Rishi, for joining us for this panel discussion. Just a quick introduction, those who are new here and joining the webinar for the first time. Recro is a community, a company which is helping developers connect with fast-growing startups. So we have clients like Swiggy, Dunzo, Flipkart, with whom developers are working with. And I lead the developers community, which is called Rebase by Recro, which is helping developers connect with mentors. Rishi is one of the mentor with us. We have had one of the mentoring session on career guidance as well. So that's what we do in the community. Would love to have you a part of that as well. So without any further ado, let's begin. Rishabh, let's start with your introduction. Would love to please share. Let's let the audience know a little bit about you. Plus, also share one fun fact with the audience. We would love to know that.
Thank you, Rashmi. Hello, everyone. This is Rishabh here. Thank you for joining. A bit about myself. So currently, I work at Astronomer as an engineering manager, and have had experience working in fast-growing startups. Earlier to this, I worked at startups like Udaan, Yellow.ai, and Axios. Yes, I've been always passionate about technology, and hopefully here to give more interesting insights in sessions like these. Fun fact about myself, I would say, so I'm sort of an offbeat traveler. So I like to travel to places that are not usually on the map or on the blogs. So I think one fun fact would be 2019 New Year's Eve, I traveled to the easternmost point of India, which is in Arunachal Pradesh. It's called Dong Valley. And in all literal sense, it is the easternmost longitude of India. And I got the first sunrise of 2020 then. So yeah, that was a very exciting, very thrilling, adventurous experience. And yeah, I always keep my bucket filled with such experiences that are offbeat and and exciting and worth telling a story about.
Awesome. I think Rishabh will have to connect with you to get certain suggestions on where we should visit next. Some offbeat location which we should be exploring. Awesome. Rishi, you go next.
Thanks, Rashmi, for having me today. Hi, all. My name is Rishi Prakash. I am working as an SD2 here in Microsoft Europe, Dublin. I have around 9-10 years of experience. I have worked in all scale of companies, small scale, large scale, medium scale, startups. The fun fact about me is that I was once part of a government organization, Indian government organization, and I was having this secure job. But I renounced, I resigned for the love of technology. So yes, and the other thing is that I love, because I know the knowledge of a person can make him succeed in life, and I have been fortunate enough to have really good mentors in my life who guided me. So I also try to help others, mentee them, mentor them. So this is the thing, and this is the reason why I joined Recro. And thank you so much, Rashmi, for giving the opportunity to interact with the community.
It's our pleasure, Rishi, to have you on board as a speaker. Right? You have been doing a lot of sessions with us, and it's every time I interact with you and people interact with you, it's always amazing, right? So thank you so much for taking out the time. Folks who were expecting Shreyans, also there was some emergency at his place, so he won't be able to join us today, but we'll take it forward. So just to give you guys the idea, we'll be having, since it's about microservice architecture, pros, cons, and implementation, we have decided a set of questions which you would like to know. So we'll be having the discussion around that to start with. And then after 45 minutes, we will be opening the house for the Q&A as well. So we'll be taking your questions live at the end of the discussion. But yes, I'm pretty sure in the initial 30-40 minutes, you will have a lot to take away. So yeah, on that note, I think Rishabh, let's start.
Awesome. Great. So I think thank you everyone for joining once again. We can start the discussion. This topic is definitely will be close to everyone's heart from software development committee. Yeah, it's called microservices architecture. And we can just kick off this session as to, just understanding what is microservices architecture, right? So maybe Rishi, I'll just throw this question to you. In your terms, what would you define as microservices architecture?
Okay, I'll talk about two things. One, like the definition, and then I'll take an example to non-technical example to make everybody understand what a microservice architecture might look like if we talk about the community around us. So in terms of definition, the microservices, by definition, says it's the smallest unit which is deployable and which can serve you some purpose. And it should be loosely coupled and highly cohesive. Now, what does it mean? It means that you are writing a service, you are creating a service, but the service responsibility, what it has to do in order to serve, it should not be dependent on others. It should not be tightly coupled with others. So it should be sufficient in itself, that is loosely coupled. And highly cohesive is that whatever you are writing as part of it, it should be that this is the only functionality, single responsibility which it is having. Technical example, if we are writing an e-commerce website, then we might be having two very segregated portions. One is your product details or product catalog, and the second is order management. So now these two are two separate details about your website. They should be kept in separate modules or separate entities. So these entities, they can be called, because they are separated, they are deployable, they are microservices. Just to make our audience understand, even in very layman basic term, is that take an example of a state in India. Now, let's say New Delhi. Now, New Delhi government is providing some service to the community, New Delhi people, population. Now, it's a whole website. Let's say New Delhi services is a website. But within this website, within this service thing, there are smaller portions of New Delhi government. One is education, another is healthcare, another maybe transport. All these departments, government departments, are segregated. They have their own ministers, they have their own budget. So they are separate microservices. They are communicating with each other, but they have their own defined agenda. They are not dependent on each other. They are loosely coupled, and within themselves, they are sufficient. So similarly, if we talk about microservices, this is the pro of having a microservice pattern, that like government is having separate departments, you have separate microservices. Example, product catalog, or example, order management, which are independently scalable. You can add more ministers, you can add more budget, you can add more bandwidth to it, you can add more capacity to a microservice. They are maintainable. They are not dependent on each other to maintain themselves. They are independent. They'll be running independent. They're independently deployable. So your product catalog is not dependent on something else to be deployed. They're also that if you're running one department in government, you're not required. In itself, you can build it on any other stack. For example, if there is one microservice, one section, which is just having Java-based tech stack. Okay, the another is which is running on maybe .NET, but they both can talk to each other with a common protocol, but they are independently deployable. Independently, we can create them. We can choose their tech stack, And because they are independent, we can independently also isolate them if there is a fault. This gives us resiliency. This gives us the ability to make the whole service remain available in the time of adversity. So these are the pros. Again, as we are talking about microservices, Rishabh, would you like to go me over some other portions which I've experienced, which are like not so good
Sure.
areas of microservices? Yeah.
I think
So
before that, I'll just sum up, Rishi, what you said, and
yeah,
that's a very
yeah,
great example that you took in terms of government functions. So I think
yeah,
to sum it up is microservices is basically a collection of services, right? And a collection of loosely coupled, as Rishi said, and highly cohesive, means highly sort of tight-knit services that have a way of communicating within each other, right? These can, and in software terms, these communicate between each other through, protocols, right? Messaging protocols like, HTTP or REST or GRPC, depending upon the use case, right? And Rishi mentioned one thing, that these are split as per certain responsibility. Like in software terms, it's called single responsibility principle. So each service has a unique capability of its own, or has a unique function to offer, right? So yeah, in simple terms, that is basically what a microservice architecture is. It is a collection of loosely coupled, highly cohesive, independently operating services communicating within each other through messaging protocols. And sort of going into the pros of microservices architecture is, I think, um, now let's see where we can apply, right? When we know when you should know when to apply a microservice architecture, when you know suddenly that the application, the number of offering that your application has slowly increases in size, right? Let's say from an organizational perspective, you have a small organization that is solving one or two particular problems. You have a smaller team, you have a smaller business unit. Um, then you should really ask yourself, do you need a microservices architecture or not, or a monolith sort of does your job, or maybe a mix of both. But I think the real use case of microservices comes at the magic word called scale, right? So when you have scaling of business functionalities, right? Let's say in e-commerce terms, you have, let's say something like Amazon or Flipkart, where you have different services in a user journey. You have your listings page, you have your inventory page, you have your order management, you have your checkout. Then you know that these are independently operating services that have a unique function, or that have a unique service to offer, right? So I think from a pros perspective, the fact that it is modular and it is maintainable independently, that is the biggest pro of a microservice architecture. Like each service can have its own, technology stack, as she said. One can be a Java microservice, one can be a Node.js, one can be a Go, and you choose based on the service capability, the service offering. Um, if it is a low latency, high throughput service, then you need something, then something like a Go service would be better. Again, choosing the technology stack depends on the use case. Again, the fault isolation aspect of it is another big pro, according to me. Let's say in a monolith, you have, say, one part of your, taking the same example of e-commerce. Let's say your payment service fails. That means everything goes down. Right? Your order management, your inventory, everything, your listings page goes down, and then that affects the user experience. But if you have it as a microservices architecture, then one service fails does not affect the other parts of the application, other parts of the user journey. And using strategies like replication and all, you can always bring that service up. But basically, what it means is you're isolating uh, fault tolerance, right? Fault isolation, in other words. So there's no cascading effect of uh, that fault going to other services. And I think in terms of team productivity as well, right? When you have a technology company or any company that has um, heavy use case of technology in terms of designing applications, you can have independently operating teams based on the business use case it is solving. Right? You can have a order management team where you have now this is me talking from a managerial standpoint, that it is very much more easier to manage a team where you have one particular team solving a one particular business problem, right? So you have a order management team that is taking care of the availability, the offering, the product, and the basically the service of that order management team. So yeah, I think to sum it up, scalability, modularity, maintainability, fault isolation, technology diversity, uh, team productivity. These I would say in summary would be the pros of microservices architecture. Rishi, what do you think would be the cons of microservice architecture?
Yeah, so all the points, Rishabh, which you mentioned, they're like advantages, and we are very tempted to go for microservices architecture always
Yeah.
because
Yeah.
because there are so many advantages. But at the same time, while microservices is making things modular, things, for example, scalable, there are certain disadvantages which comes into picture. I go back to the same example which I was taking of a government. Now in New Delhi, there are two ministries. One is education, one is health. Now take them as two different microservices, but they are required to communicate with each other. So when they communicate, there is a overhead of there's a latency because one will be sending some data to the other will take some time, will send the data again back on the network. So there is now a latency introduced. And this latency can be minimized, but cannot be made zero. It will always be there because the network speed is limited by the speed of light. Maximum you go to speed of light. This is one. So there is this overhead of data which you are sending. It's a challenge, it's a complexity. So it's a communication overhead. The second is that because now you're having two different microservices, two different ministries, you have to allocate them two separate budgets, two separate set of ministers, two separate set of containers, or we say pods, or wherever you are running. So the infra will be now more complex. And with this complexity comes even that you'll require more set of people or more set of capabilities. A capability which was there for monolith. Now you require another set of capability to handle microservices-based infra. This is another set of overhead or complexity which comes into team skill set level. Now, because you are running two separate set of infra, this will also cost you something. So you'll be paying some money, even some more money. So that is your operational overhead. So these are 3-4 points, which are again, these are disadvantages of having that loosely coupled architecture. But we have to take these into account when we are going for a decision to be made between monolith and microservices. This is what I think. What do you think?
Yeah, definitely. I think as and when you scale and as and when you reach a distributed system, the typical distributed system challenges would be, addressing issues like latency, right? Definitely when you have different services in one code base, the time to communicate between function calls rather than communicate between HTTP calls function calls will be lesser than that of HTTP calls. So there is definitely a latency aspect, which is a very important aspect when you're building more real-time systems nowadays, right? Everything is more real-time and you want real-time capabilities. So yeah, I think one is the overhead of latency and communication. I think it also adds to a lot of microservices also adds complexity, right? Just managing and coordinating with such large number of services can be challenging in terms of, troubleshooting, right? Let's say you find an error in one service and then you have to trace it all the way as to which service was that error originating from, right? So you need to have proper tracing mechanisms, monitoring mechanisms, troubleshooting mechanisms for as and when the number of services in your stack increase. So you might see one of the, let's say, say one of the services failing, but the error might actually not be coming from that, but it might be originating from
because something,
call failing from another service.
Yeah.
So the traceability aspect is what, at least from my experience, is what I faced. I think also the whole aspect of inter-service communication, going back to a latency, like many people fail to actually consciously fail to design their microservices architecture in terms of what is the right communication pattern I want for my service, right? Is it should it be synchronous in nature? Should it be asynchronous in nature? On what basis I should choose synchronous and non-synchronous? On what basis should I choose a REST protocol over a GRPC protocol? I think those are, in general, we are in the nature of developing systems and scaling. we often miss out these complexities and miss out these gaps in terms of, addressing inter-service communication.
Right.
And I think another very crucial con, I would say, is data management, right? Every service has its own database layer, right? In a monolith, you have just one database layer, one application layer, all the services just interact with that database. But when you have so many services and each of them have their own database layer,
Right.
Maintaining data integrity, consistency, and synchronization amongst different database, that can,
That will be
that can
challenging.
lead to complexity. That can be
Very
challenging.
challenging. Yes.
You have anything to add there on the data management side of it?
No, this is the point which you raised is it's absolutely relevant to the microservices pattern. And I have heard instances where the data go out of sync because two different microservices, they are handling the database, and they have like a separate system just to make the two databases synchronous.
Right.
Yeah, so this happens. So I totally agree that to handle these database management layer along with multiple microservices, it's going to be challenging. And actually going back to the decision which we are required to make when we are developing a microservices pattern-based architecture over what kind of communication we choose between two entities, two microservices, or even the communication between, for example, you are an independent service, a set of microservices, but then you are talking to somebody else. Taking an example of these websites which allow us book my show. So book my show is like a middle entity. You go to book my show goes to PVR. Now PVR is handling its own database, but book my show is just talking to PVR on your behalf. Right. Now what should be the communication between you and book my show and PVR? And within book my show, there are multiple microservices. How they should communicate. One, it's sort of template which I've created for myself just to understand what should be the communication decision which should be made for these services. That if book my show is talking to PVR, if they communicate synchronously. Okay, now first I define synchronous and asynchronous. Synchronous is that when request is made from one entity to another, and you are waiting, or the other entity is waiting for the response to come back on, only then it will proceed. This is synchronous. We can say asynchronous is that when request is sent, but then you won't wait for the response to come back. You will just go ahead, do your work, and when response will come back, you will then take care of it. So if you keep book my show and PVR communication synchronous, the latency is going to increase, the end user experience is going to deteriorate. What you can do is that we can create a webhook. Now, what is a webhook? Webhook is just like a REST endpoint, a post REST endpoint. You send a request on the post REST endpoint to the PVR, and then book my show keeps on doing its work. PVR, in some point of time, it will understand the request, generate some response, send response back to you, to the book my show, and then it will take action. So this is one. You can, if you think that synchronous communication is enough, latency is not high, this is the simplest thing to do. Okay, but to increase the user experience level, to lesser the complexity, and to make the failure rate go lower, you should choose this way of webhook based asynchronous protocol. Now within book my show, there are multiple microservices. I believe these multiple microservices, they can also talk in the same manner. They can also talk in synchronous or asynchronous manner. Another thing which we can introduce inside book my show microservices pattern is that we might introduce something like a queue, a messaging queue. Because two services are deployed on two containers or two pods or some kind of server, they have a limited capability over number of requests they can serve. If the ingress means number of requests incoming, this rate is too high, those servers, those pods, containers, they will fail. So what you do, you keep a middleman between two microservices, which is like a messaging queue, which will take a request from somebody, make the whole communication asynchronous. Now we are not talking to the other service directly. You are talking to some middleman The middleman will take care of delivering the message, delivering the request to the other entity. Other entity will generate response, give back the response to the middleman, and then middleman will deliver it back. This is the third way. So synchronous, within synchronous, there is one way. Asynchronous, two ways. Either you use webhook using HTTP post, or you use something like messaging queue. Using messaging queue, you are basically introducing a middleman, which can, in terms of in cases of when it's that the ingress is really high, the middleman can ensure that the message actually gets delivered. Now, another possibility is that the microservices, let's say there are two microservices, A and B. A wants to talk to B, and B is not there. B is down. Whatever A is sending, that request will go in vain. In this case, also you can introduce this middleman. The middleman will make the whole communication asynchronous. Also, the middleman will ensure that the request which A wants to send to B eventually gets delivered. Okay. So these are the three things which I think it's a template for me, where I decide how to go for a communication system decision. This is one. Do you want to add something here, Rishabh?
No, I think I agree with most of the points. Like coming to implementation strategies of microservices, deciding the right communication pattern is very important based on the use case and based on what your service has to offer, right? So going through common communication patterns in software development, one would be as you said, the synchronous model, where you send a request, the client sends a request, then the client waits for a response, and until the response doesn't come back, there is no sort of action taken. And these are like, I think when you can use a synchronous pattern is simple with, when you have an API and API layer and a database layer, simple data fetch would be a synchronous call, right? Which have like short, short compute times. But then when do you choose an asynchronous communication pattern? When you have longer response time, let's say, for example, video rendering, or, sending a notification, or you don't want and this is from a user experience standpoint, right? You don't want the user waiting on that operation for too long. So that's when you go for asynchronous. And now again, going deeper down to how do you choose a tech stack that supports this asynchronous and synchronous, right? Whether it's a Java based, whether it's a Node.js or event-driven based tech stack. Again, it all depends on the use case. So I think carefully designing your architecture and carefully designing your domains, right? Being domain-driven in approach in terms of microservices, and picking each domain and understanding what that domain has to offer. That's how you can sort of use the right implementation communication patterns, right? Then also, and I think one more thing is, how do you choose? Now, I think GRPC is a very common upcoming sort of protocol, right? Compared to REST. REST has a lot of support. REST has a lot of popularity. Everyone understands REST. It's simple JSON XML based, response request. But GRPC, very few people are still understanding the whole concept of protocol buffers, how and when it is used. So I think where GRPC wins over REST is, I think, managing large payloads, right? Where GRPC has a way of rendering into binary formats, right?
Yeah, it's like a shorter, smaller payload.
Yeah, and as and when we design more real-time systems, that's when something like GRPC systems have a plus point over REST, right? Because they just handle, they have a two-way sort of communication. I think REST sort of implements two-way through WebSockets and other protocols, but GRPC in default has a two-way style of communication where you can just allow data streaming.
Makes sense.
So,
totally makes sense.
Yeah, so I think that's on the communication pattern aspect of strategy. Then I think we come to service design, right? Service design and boundaries. How do you know the appropriate level of granularity when you're designing a microservice, right? How do you know when it is time to split a service into microservice, or how do you know when it is time to sort of combine two services into microservices, right? And I think that's where you use the single responsibility principle, right? Or the domain, domain-driven
domain-driven approach. Yes.
Domain-driven approach.
And,
this
is
Good.
I would like to point. I add a point here is that this is a gray area, and this is like your understanding of when to split a
Mhm.
monolith into microservice, and my understanding could be different. You might want to, okay, you might want to split it earlier. I even might want to go for a higher level on which we'll split. So this is the gray area. So I think we all should strive to go with a single principle which can be followed. And if that principle is followed, then your understanding and my understanding is same.
Right.
It's very similar like to when we agree on design patterns. So when you say it's a builder pattern, I understand what's a builder pattern.
Mhm.
Similarly, and when you mentioned the point is very apt that when you say it should be based on domain, not on something else. So instead of designing your microservices from application layer to then business logic and then later, we
Mhm.
should basically try to design it from the domain side. Example is that, and when we were earlier taking example that you have an e-commerce website and the e-commerce website is having one product catalog and another is order management. Now they both are having two domains. Product catalog is having product as domain. Order management is having order as domain. So if you start this journey from user side, from application side, then you might have put them both in the same because they're working together. Okay. Then you might not see the difference between them. But if you start from the domains of product or domain of order, then you know that they are going to be two separate entities which will be having responsibility of handling their own things.
Correct.
So this domain driven approach is very beneficial when you try to decide the granularity of a microservice. So +1 on that.
Mhm. Mhm. Yeah, agree. And I think even going to the technical aspects of it, right? Let's say you have a part of your application layer that requires low latency, right? And then you have another part of your application layer that does not require a lot of low latency. Then it is a good time to split that as a microservice. Keep that as a separately operating service. Like say, for example, payment services should be extremely low latency. You don't want any failures there, right? High throughput and low latency.
Yeah.
Real-time streaming services should be. So that's when okay, it's time to split that. Authorization services, which have, let's say at scale, you have more users, logging in, logging out. You have more authorization requests taking place compared to the number of orders, right? So it doesn't make sense to couple authorization with order management. That's when it is a good split, right? And even in terms of data ownership, right? So data ownership and access patterns vary from service to service, right? So if there's a specific data layer that is frequently accessed and compared to a data layer that is rarely used, right? That can also be a way to split that because that particular data layer that is frequently accessed that has more risk of failure and also has higher chances of scaling compared to something that is less frequently accessed. So yeah, data ownership, latency based on latency and performance. That's where you and also deployment also is a very important criteria. Right? How with scalability the deployment or overheads increase, right? That's where in microservices you have the continuous deployment strategy, where you have some services that needs to be every day every day you're pushing a commit to production or every day you have a
push it goes to production. Yeah.
Right. Other services you have longer release cycles. Depends on where you want higher availability, right? You want bug fixes faster for these services. But the deployment aspect of it also sort of can be a factor. And I think team structure wise also, this is from again management standpoint that when you have again all depends on the what the service offers, right? Based on what the service offers, you'll have teams aligned in a way to work to build that service, to keep that service, to maintain that service, to scale that service. That's when cross-functional teams and communication between cross-functional teams can also sometimes be also an overhead in Microsoft.
Absolutely.
So having so having the right team structure strategies also we often miss out. So I think often more than technical, there is also a management aspect of Microsoft because there is also
it
teams.
Depends on your organization size, how long you have been into the product. Is it already GA or not? Is it already available to the public or not? And also there is one point which I want to add here, and when you're talking about it, I remembered it, is that if we are not sure about whether something should be a microservices now, but it might be a microservices in future. Example is that, let's say you are sending data and receiving data from microservices, which are encrypted. So it comes encrypted, it goes decrypted, something like that. So it's dependent on a certain logic, which is doing encryption and decryption. Now this logic is, it's common for all the microservices. This is the scenario. But at this point of time, because this is tiny and you don't want to make another complex microservice architecture infra decision to put this in a separate microservice, then instead of keeping this logic bundled inside all microservices, you can make it a separate library.
Okay.
So that in future, when you want, okay, this is a library, which is at this point of time, I'm just embedding. I'm just like having a package reference. In future, you can just expose a presentation layer, make it a separate microservice. So even if at this point of time, you're not sure this can be a microservice, make it a library so that it's at least decoupled in a way. In future, you can make a decision, may it remain like this, or you can make it a separate microservice. So this is another portion where you decide the granularity.
I like that point, Rishi. So in terms of, is this related to security management and let's say security?
No, it could be, yeah, it could be like anything. It could be like a security thing, which is common for ON. We usually use these libraries, which are inbuilt, where it's not a third-party library. You are devising them within the team, but within the team, they're used by all the microservices. So now it's a library. You're keeping that in a remote repository, embedding that with the help of package reference. But okay, you might want to scale it up. For example, now your product is just building. It's like a prototype or something. So the library is not having that high ingress of requests. In future, that encryption decryption utility is going to have a lot of ingress, because you also want to scale it. You also want to make improvements. So then you don't want to touch each of the microservices. For now, it's okay. Then you want to segregate it. Then you want to segregate it as a microservice, scale it so that it can be used. So this is one of the thoughts.
Got it. Have you ever faced any testing and debugging overheads when you're working with Microsoft architecture?
Oh yes, and then that made us introduce something else. So not in Microsoft, but because I was working in the last company, and the thing which you mentioned is that you're making a request. The request is then passing. Your user journey is starting from your user request. Right. Then it is passing through for example, take e-commerce website. Then it is passing through your product catalog, product selection, order management, and then some facility which delivers. So these are multiple. Now let's say it says that it failed in facility, the last portion, but it could be because that product catalog did not generate correct order or product information, and then it went through order management, but then eventually it failed. In those cases, the strategy which we have introduced is, it's like a distributed logging. It's a vector. Now this vector is passed as soon as the user request hit your first system. So there you generate something called a vector. Now this vector is two parts. One part is static, another part is variable. The first part tells you a unique request came in. The second part tells you which service it currently is. So each time it passes through a service, that vector is, the second portion of the vector is getting increased, and this gets logged. So in the logging, you can then see, okay, this is the request which came in, and with the first part, you can then see the whole journey. And then you can also decide, okay, this is the second part which goes to this particular service, and this is where it is failing. So this is how we are handling the distributed logging. Yes.
Distributed tracing. Okay, yeah. Distributed tracing mechanisms for debug. Got it. I think the testing, I faced personally, testing aspect of it is very important to have in an organization. It's very important to have the discipline of writing tests. I think I've seen that definitely in high quality products, you need better testing strategies. And microservices, where that sort of comes as an override, is when you have, let's say, a 50 service or 100 service microservices. Yeah. You're writing independent functional unit tests, that's fine for your service. But then if you're writing integration tests, right? Integration, end-to-end tests, regression testing to test the entire microservice architecture, how they talk to each other. I think those are one of the largest overheads I've seen. And I think
Yeah,
tackling that
I,
can and I think that definitely there are right frameworks and tools in place, but designing for appropriate test coverage, appropriate fault tolerance before pushing to production, automation, a lot of automation around testing, automated
this
tests.
makes sense.
That's another
Yeah.
thing. I
Yes,
feel
and even with this is that you aptly said that even though you are having unit testing and your
Mhm.
piece might be working very well, but as
Right.
soon as it becomes part of the whole product, it
Correct.
might start then creating a failure.
Correct.
So
Correct.
yes, this made me remember that what we also have a system which is like end-to-end tester, but it's totally segregated from overall system. It's
Right.
deployed somewhere else and it mimics user. It basically mimics a user. And then it sends requests to all of the environments. So our environment, they are deployed in multiple regions. So then it mimics a user, keeps on sending that request to all the regions where it is deployed. So as soon as you hit your dev, so as soon as we push your, so we have like the least level is having dev. And as soon as you push your code to dev, this particular system is going to hit dev, bombard, it's going to continuously hit. And if your code is failing on dev, it will then start reporting it in our telemetry. So in telemetry, we'll get to know that. And because it's failing in telemetry, then we can generate for the on-call engineer a ticket that something is failing in dev. It's a very low severity ticket, but people will get to know that something is failing.
Right.
So this is how we are handling the overall end-to-end testing.
Yeah, definitely. That's a great strategy. I think having the right alerting mechanisms in place for failures. Well, coming to data management and consistency, I think what would be your thoughts on securing communication between microservices and protecting sensitive data? What are some good strategies for you there?
Yeah. So now this is very challenging piece because it hits a lot of portion of your overall architecture. Let's take the journey of a request, and then I talk about what I think that how it should be handled. So let's say user is sending request, and a user is a client, and then your service is on server. Okay. So this is the first portion where user is sending a request on network till your server. This is one portion. The second is that as soon as it goes inside that server, there should be a layer. Example, it's gateway, or even if you're not exposing gateway, it's a load balancer. But let's say it's a gateway. And then from gateway, it goes to a cluster. So the cluster it might be having an ingress. The ingress could be Nginx-based, something.
Right.
And then eventually there are multiple ports. So your request from user goes to API gateway to ingress in a cluster. And then within cluster, there are port-to-port communication. Now, how this can be handled is that this first is the transport layer. This is TLS-based security. So everyone who is running a good company, they'll be having a digital certificate for their DNS. Yeah. So this is where the TLS comes into picture. So TLS security takes care that the user is actually hitting authentic service. So this should be HTTPS based. This is what you should be taking care of your digital certificate properly, renewing it, everything else. The second is that once you are inside your service, then it's your API gateway. API gateway will take care that a data which is coming into your system, it's authentic from authentic source. Somebody is not trying to send a DDoS attack on you. So this is where you handle that kind of data. Okay. It also takes care that there is a rate limiting, which is applied based on a policy. The policy can be dependent on a lot of things. It could be IP based, it could be API specific. It could be that the user is sending something, so user is having a certain customer ID, so it could be customer ID specific. There also this is how you're handling the data at API level, and then it goes till ingress Nginx. Nginx ingress for those kind of systems, they can then define their own rate limiting for internal systems. Their own if this is the request which is coming, and this is the path. This path I recognize. This path I do not recognize. So only the paths which are recognized, they are allowed. So till this path, this is how you're handling. And then internally, what happens? Let's say there are multiple pods. Let's take an example of Kubernetes-based architecture where there are multiple pods and there are like containers. They're talking to each other. Now, there could be a malicious activity inside Kubernetes also. So if a pod is talking to another pod, how do they know that the other pod is not mimicked by some malicious user? So there are systems like which create a service mesh. What is service mesh? In simple example, in simple definition, it's like one pod understands that the other pod is authentic or not with the help of TLS. Again, there is a digital certificate which is attached with each of the pods, and they know the other one is authentic because they have the certificate. Otherwise, they reject. Right. So this is the overall journey in which you can secure your whole data. And now there are systems also that you want to keep your data in database, then you want to keep it encrypted. That is one more. Data at rest is encrypted, more secure. Even there is one more thing. So in the whole journey, if you just look closely, if you think that when data is in processing, it's not encrypted. It has to be decrypted. Otherwise, it won't be processed, right? So there are new kind of systems which are called, okay, I don't remember the term, but what they do is that they basically create a secure boundary of address space inside your CPU. And that boundary cannot be accessed by any other program, because this is how virus work, right? That the virus become part of your address space, then it maliciously try to invade somebody else's address space. So right. they create a boundary inside your CPU also. So your CPU is also secure. Now this is extreme level of security, extreme level of data management, that it is not being leaked. So this might not be useful for every use case, but if there's like a finance-based data, those kind of areas where it's very critical, if you lose something, then you can also introduce these kind of systems. So this is how I think these are all the systems. Apart from this, when you're within your pod container, there is an application which is running. So that application might require you to provide some token. That token can be identity token, access token. It can be generated from an IDP, identity provider, but then it decides within database how much you can access.
Right.
Your authentication and authorization level. So this is in all the areas we can handle the data.
Got it.
Yeah.
I think the security aspect is very, very crucial as in when you have more independent data layers, right? And more points of points of communication interjections.
Yes.
And that's where that microservices is more friendly with a cloud native approach, where you have cloud handling a lot of these security aspects through cloud security policies. Even Kubernetes, for that matter, handling microservices through Docker containers and Kubernetes have pod security policies in place to take care of all these aspects, what you mentioned. So, I think that's a very important important factor, Rishi, you pointed out in terms of security, and thanks for elaborating there. I think we can open the floor for Q&A, Rishi. Is there anything you would like to cover before we mostly covered most of it, right? I think
most of yes.
Most of
the things are done. Yes.
Yeah,
so
we have certain questions in the Q&A.
Let's.
Rishabh, can you see the questions?
Yeah, I'm just.
Or should I read it out?
Yeah, I can see the Q&A. Okay. Well, could you provide us with a broader understanding of GRPC?
Yeah.
That's a good question. So I think GRPC and I think there are two very famous protocols, one is GRPC and REST. GRPC is more to do with protocol buffers, and the use of GRPC is for handling larger loads of data. And it uses the concept of protobufs, protocol buffers, and it is usually a replacement to REST when it comes to handling again larger loads of data. And you have the aspect of low latency and high throughput, where you cannot factor in delays or lags between request and response cycles, and the whole aspect of real-time communication. two-way communication. I think that's where gRPC sort of wins over REST is what it's a very broad high level perspective.
Yeah.
Rishi, anything you'd like to add there?
No, this is to the point, the portion which you covered with like gRPC smoothly integrates with protobuffer. Now, protobuffer is, if you're using Java, you can serialize, deserialize with Java serializer, deserializer. If you're using some other tech stack, or even in Java, you can use JSON as the common serializer, deserializer protocol.
Yeah.
Now, all these things, even with like Java native serialization and with JSON or XML based serialization, the thing is that if you're having a very high value means high weight payload, it's going to take time to transfer that over the network.
Correct.
And if that network is like within your microservice architecture, you want to delay the latency. Okay.
Mm-hmm.
This is when you basically zip your payload in the protobuf. And then you send it protobuf. The protobuf is having a very small size. It is having its own architecture. The JSON is like very user friendly, like highly readable, but protobuf is not. The advantage is that it is zipped. It's very small, and your latency is now reduced.
Correct.
So that is where the gRPC comes into picture.
Yeah. So the data format is the difference, right? The data format, as she said, in the REST you have XML and JSON based, and gRPC you have protobuf, which is protocol buffer, which is basically binary serialization format. And binary serialization format is much faster to serialize and deserialize compared to JSON and XML. It does, addressing the latency part of it. The communication style between REST and gRPC, REST is mostly, you have the standard get, post, put, delete methods, and it's usually used for CRUD operations on data resources, and has a typical request response model, which is exchange in JSON and XML format. gRPC is more high performance and typically language agnostic, and it uses RPC, right, remote procedure call framework, over the network HTTP layer. And also it uses HTTP2, right? REST uses HTTP1. HTTP2 has its added advantage over HTTP1. And also use cases that I would say REST is normally, in my opinion, REST is normally used for public facing APIs.
Yeah.
Where it's easier to document, easier to understand. gRPC is usually used between internal service communication.
Right.
Yeah, I think we covered most of it.
Okay, one more, just one shout out that I would like to give to folks who are live on LinkedIn. There are 40-50 people who are listening live. If you have any questions from Rishabh and Rishi, please post in the comment and I'll take it up. Yeah.
Cool. Next question. When dealing with eventual consistency and distributed transaction among microservices, what are some strategies to handle scenarios where data integrity becomes crucial, such as in financial applications? Yeah, that's a very good question.
That's a good question. Yeah.
You want to take that one, Rishi?
Okay, so my thought, and then you can augment my thought, is that when you have, so you decide what kind of system you have, and because it is mentioned here that it's a financial application-based system, you don't go for eventual consistency. You go for strong consistency. Okay, so when you're saving in your data, taking a step back, when these eventual consistency, strong consistency comes into picture, when you are having a distributed system. Now, what is a distributed system? Because you have basically divided your database based on certain factors. And then you want to have a mechanism in which you want to keep all the databases in sync. Okay. Now, eventual consistency means that eventually all of the databases, or the copy of databases, they will be in sync. In such cases, if you have financial application-based system, you don't go for eventual consistency. You say that, okay, I have 5 replicas of my database. I want at least 3 of them to say we have updated. You have like a column, and then you say a column is having strong consistency because more than half of the column says we are now updated. So this is one strategy which I think it should be used if you are having such crucial applications. What are your thoughts, Rishabh, on this?
Yeah, I agree. I think strong consistency in terms of since the use case here is financial applications, you don't want to be having any case of data losses. And yeah, having a more strong consistency, strongly coupled system will definitely be the right choice here. And yeah, rest of the points I agree with you, Rishi. So
Makes sense.
yeah, moving to the next question. But what is the best way to handle debugging the microservices when fault occurs in the services, especially when many services are available? Yeah, I think we covered this during our discussion, and just reiterating that, having the right tracing mechanisms, the example of distributed tracing, what the example we took in our seminar was having the right logging and tracing mechanisms to easily to easily detect where the error is coming from, where the fault is coming from, which service it is coming from, and also having the right alerting mechanisms in place for teams
Yeah.
to jump on it and
Take productive action.
take productive action and take fast action on that.
Yeah.
So yeah, distributed tracing mechanisms and alerting mechanisms is something would be a good strategy to sort of follow when you're handling when you're debugging microservices and faults in microservices application. Next question we have is, what are the most common anti-patterns or pitfalls to avoid when designing and implementing microservices? Rishi, you want to take it first?
Yes. It's like, don't be paranoid about going microservices. Don't be like, I have to keep it very granular. These are the anti-patterns, because anti-patterns means though you are going for microservices, but then the complexity, the overhead becomes so high that your overall purpose is defeated. The overall purpose is to keep your service run smoothly. Now, if that can happen with monolithic, very nice. If you think that your service should be divided into microservices, and then there will be some advantages in terms of, for example, you are running a team, you're running a prototype. In prototype, don't go for microservices. Go for monolith, experiment, it works, start serving from that prototype or that MVP to the consumer, and then you work on dividing it into multiple parts. The issue is that why people are not able to divide monolith into microservices, because in the very first go, when they're writing code for monolith, they write it so tightly coupled that it won't be possible for it to segregate into multiple. If you're keeping your code modular, then you can take individual modules as separate microservices. So be highly skeptical, push your boundaries to make your code very much modular. If that is there, even though you are keeping it monolith for now, eventually you can segregate that into microservices. But don't be very paranoid about making everything microservices. That is going to add extra overhead. We talked about disadvantages of having microservices, and that will make the overall system less efficient. So this is my take on this.
Yeah, definitely agree with you, Rishi. I think to add to that is the anti-pattern starts with the train of thought first, right? That you don't think that microservices architecture is the solution. And it is the right way. It's the best way. It's the right way. You remove that thought first, that if I'm doing microservices, that means I am adopting modern strategies. I'm adopting best practices. Microservices does not mean best practice. Microservices is, and monolith is actually it is strategy.
They're not like they're not like one is lesser than other. It's not like
exactly. That. It's not like that. It's not like one is lesser than another. It's like just using the right strategy at the right point of your application design. So I think I think it, again, to reiterate, it's just you should know when it is the right time to split your monolith, split your code base into another service, and you don't start with designing 5-6 microservices. You start with a monolith actually first, and then since you're at first you're handling lesser scale, as in when you're scaling, the number of requests that are hitting your application goes up. That's when you start seeing bottlenecks, and that's when how you address these bottlenecks. Microservices can be an effective strategy to even address these bottlenecks.
Yeah.
So I think that's a popular approach to a sort of.
This is how it happens. Just ensure that you're writing your code with domain in your mind,
Yes.
not the other way, so that it's
Correct.
modular. Yeah,
I think it comes with writing the code. It starts with the code design, right? You design your code
start
as
with code
Rishi said,
design.
design your code domain-driven design, right? You have a separate function for this, you have a separate function for that, different module for this. When you have modularity within your monolith, that's when it will be easier to spread to microservices. Okay, moving to the next question. What is the most effective scaling strategy for microservices when dealing with multiple services?
Most effective. Okay.
Okay.
Yeah.
Good.
Okay. Yes. I'll add my thoughts. You augment it with your thoughts.
Yeah.
So it's not like most effective. I give you scaling strategies which I know, and you can divide the whole scaling of microservices into two parts. One is that, do you want your service to stay? For example, you are Netflix, okay, and Netflix is a globally available service. Okay, one is this. Another is you are Dukaan.com. Dukaan.com is India-based system. Okay, so one scaling is that if your service is geo-available, do you want to replicate your service into multiple regions for the region-specific audience? Okay, because you are Dukaan.com, you might not want to put your servers into Australia or USA because there is no audience there. You want to keep it India-specific. So one scaling is that you replicate your service, whole service, into multiple regions for your audience so that the latency is lesser. For Australia region, based on the DNS, whatever DNS you use, the DNS can ensure that the request is actually going to the nearest geolocation possible. This is one scaling strategy that you are basically multiplicating a service. The second is that inside your region, then you have multiple, let's say you have Kubernetes. I talk about Kubernetes, or you have multiple containers or multiple pods available. Then you can decide based on the load which is expected, a minimum and maximum range of number of pods which are going to be there. Let's say you expect that your one single pod can handle 1,000 requests per second for a particular service. And then you expect that in the peak time, it might be possible that the load is 2,000 requests per second. So you define a minimum, that minimum, at least I need one, and maximum I can go to 3, a little higher than the maximum load expected. And then you leave it to something, systems like which can auto scale based on the load which is coming. Example, there is one system, HPA, horizontal pod autoscaler, which basically works with Kubernetes. Based on the ingress means incoming rate, it will take decision, okay, now I need another pod. And then it will create or destruct depending on the number of requests which are coming, and it will scale horizontally your system. So this is how you scale inside your system. And the other ones which I talk about is how you scale in the regions popular so that you are serving your audience with least latency. Yeah, these are the two things which I want to add. Anything, Rishabh, which you want to add?
Yeah, I agree, Rishi. I think I'll add to that is whenever I implement scaling strategies, I strongly use observability and monitoring before I scale. So I think one what do you say one rule to sort of or one instruction to put on your rule book is basically place effective monitoring and observability tools in place to monitor your service loads, right?
Yeah.
And this should be across all services, and obviously you have tools available for that. And when you see that, when you have, as she said, during different frames of time, you'll have different peaks, right? And when you observe peak loads at a particular time, and for which particular service, then you know that that is a service that can form a potential scaling bottleneck, and that's when you know you need to scale that. And now scale can be depending on, as Rishi said, regional, right? If you have, say, if you're designing an application at a global scale, you might have at 12 p.m., you know, the India servers will be facing more load. At this particular time, the US server or any other server will be facing more load. That's when you know that this particular region needs to be scaled. This particular region needs to be, you need to horizontally scale your services to minimize the latency of the request. And coming down from a global to local, let's say, for example, like Rishi said, Dukaan, when you know a particular service, let's say in terms of e-commerce or Dukan, let's say an order management service is going to hit scale at a, let's say you have something like, let's say Flipkart's example of big billion. If the Flipkart has a big billion or Amazon has a Prime Day sale. During these hours or during these days, you know that the listings page, the order management pages are going to be services that are going to be scaling,
Bombarded. Yeah, yeah.
bombarded with so many users, the authorization. So I think in terms of scaling strategy, I always design my services to be 2x, 3x the scale it can handle. And when you know there are potential ways for that to break in the future, have the appropriate monitoring and alerting strategies in place. And with Kubernetes, you have protocol, you have capabilities like horizontal pod auto scaling that automatically scales the pod based on the load and request. And obviously, going more cloud native in your approach, you have the major cloud providers that allow you to, automatically scale up your resources.
Yeah.
So yeah, that hope that answers your question, Abhishek. Moving to the last question, I think. Yeah, Sagar, how can we manage the complexity and ensure maintainability when the application grows? Yeah.
Yes. So I think we talked about this in multiple aspects of the overall discussion. We talked about this multiple times, and this is, I strongly believe, and this is very specific. You can disagree, Rishabh, with your thought. I personally believe that if you go with domain-driven design, if you keep your code very modular, then in terms of complexity, you will be making it less complex, the overall code or how the code is talking to the other portion of the code, and the maintainability will then be higher. And saying this is very easy. I mean, when I say like domain driven, it's very easy. But when you go in design, then it becomes very challenging, because then you might not be able to understand that how to keep the overall system such a way that, take an example, today you are using a system A, or your application today using a database A. Okay, the database A is NoSQL type of document based NoSQL. And tomorrow you are going to use graph. Even if you create your system in such a way that it integrates with every document based system very well, tomorrow you are plugging in another database, which is having a totally different set of requirements. So you have to ensure that your system, your application is so modular that you can plug in and plug out third-party libraries in a very efficient manner. And this is how you keep the overall code maintainable. If this is there, then this segregates not your like code modularity, not only segregates your challenges into a specific portion, that if you are having some issue with product catalog, you focus on this particular repo or library. If you're having a certain problem with order management, you go to different library. It also helps you to segregate your team into specific shorter subteams. Then they can handle their own specific subparts. So this is my overall take, that you go and read something called clean architecture, go and read something called domain-driven design, and then you understand how to make the overall system in such a way that, okay, now you understand it, and now your the code itself is less coupled, loosely coupled, and highly cohesive. It's not just like microservices, but the code itself is at that level. This is my take on this.
Yeah, I completely agree with what you said. Domain-driven design is just the right way of looking at microservices, just because microservices, the whole definition of microservices revolves around, independently coupled business logic and domain offering what the service has to do.
Yeah.
I'm going to jump on to a couple of more questions we have from LinkedIn.
We are way beyond time, but let's take out 10 more minutes. There were a few questions which came over LinkedIn chat as well. I have posted them in the comment in the chat box.
Okay, Rashmi, we have some time. We could maybe answer this.
Rishi, can we spend like 10-15 more minutes?
Yeah.
Okay.
Awesome.
Great.
Cool. So the first question is, can I replace Django Flask backend calculations, exposed APIs and modules other than DBMS with just microservices? If yes, how can I protect the code or algorithms I have used previously in custom backend now as a microservice? So I think what question is trying to say.
the question is trying to say is that they have like a engine, backend engine, which calculates, and it is
Yeah.
currently integrated within the system only, and it is being used by some algorithm or some part of the system. They want to extract that engine out as a microservice.
Correct. So I think he has a Django or a Flask application, which has certain modules probably for certain parts of the application layer doing backend calculations, and some exposed APIs. Now he wants to convert that into microservice. So if he has to convert that into microservice, how can I protect the code and algorithm I have used previously in my custom backend service in my current microservice? So it looks like this is more into security and service protection layer of it. So I think let me take my give my thoughts on this. So from a security standpoint, there's not a lot of ambiguity that increases when we move from a monolith or from a more consolidated backend to a microservice. You are just moving your business logic or your application layer to another server or another service, and you're exposing that as an API endpoint, right? So what you're doing looks like you are doing the same. You're exposing that as an API in your Django modules. Similarly, you're going to just move that to maybe another Django or maybe another service, and you're exposing that as a REST API for you to communicate and make use of that function. So in terms of protection, based on your deployment strategy, based on where you house your code, and how you based on your API layer and security around your API layer, putting the right strategies in place, maintaining OWASP security protocols, like, if you're having a REST API implementation, then things like, you have your basic OWASP security rules, right? Cross-site scripting attacks, or you have DDoS attacks, managing that at this API and security layer. That's how you can sort of protect your code, in my opinion. Rishi, any thoughts?
No, I think this is what you have just covered is very relevant to what he's asking. If we understood the question correct, and I believe this is what I want to, what I also wanted to say, and there's nothing more which I can add here.
Cool. Next question. I'm working on a personal project which I implemented backend in Node.js. Currently, I'm struggling in deploying the backend in AWS. Could you please explain how to implement the deployment? There are 2 API gateways and 2 web apps which needs to be hosted in subdomains.
This is quite broad, and I think this is a little out of the agenda.
Okay.
Yeah.
Let's move to the next question.
We can move to the next
question. Rishabh, if you can, if you want to take it up, you can.
Yeah, I think I'll to just answer that in some way, but this is more of a cloud deployment strategy. If you're using AWS, how do you want to set up your cloud architecture infrastructure in terms of the API gateways, in terms of your service and application layer? So in terms of the deployment, you can use different. Like, personally, I'm saying if you're working on a personal project, I would use something like Lambda, right? AWS Lambda, which makes it very easy to deploy. Like, you just have function as a service. The deployment is absolutely easy. You have AWS handling your service, the entire deployment side of your service. All you have to do is just do an AWS deploy or a Lambda deploy, and you have your deployment for production stage. So I think if you're working at a scale of a personal project, you can try AWS Lambda. Moving to the next question, could you please explain more about microservice architecture in Node.js and API gateway?
Rishabh, if we have already covered this question, any of these questions in the conversation, we can skip.
Sure. Yeah, I think we have covered this. From a Node.js specific standpoint, microservice architecture is very, again, if you're talking about Node.js, then it comes to why you're using Node.js, right? If you're using Node.js for the communication pattern of it being event-driven and asynchronous, in that way, you'll have a different service for that. So I think we can skip this one because we have covered this. With the help of distributed traces, we can find the root cause of failure. Not sure if that's a question. But yeah, with distributed.
I believe they're asking that with the help of, we can absolutely. It can pinpoint to the exact failure.
Yeah, distributed tracing mechanisms can definitely help you find the root cause of failure. Next question. You mentioned in future we can have utility for authentication at different places. My question is, it takes authentication at all places. Let's say authentication source is down or giving error. What is your view of this? Okay, so I think as per my understanding is you have an authentication service and you have
we have like a one single service which is responsible for authentication. And how do you scale? Like if it goes down, you basically, as Rishabh explained it a number of times, that because this is a service which is going to have very high load, you ensure that this remains scaled. Okay, you depending on, so you, as Rishabh said, that you have observability, that this is the load which you're expecting, and then you plan for at least double the load for that particular service. So, yeah, this is how you. I think we covered this one.
Yeah, I think simple is just avoid any single point of failure. So if you have an authentication service, which is going to hit scale, always have 2 replicas or 3 replicas of it. So one fails, then you have the second replica handle it. And have an Nginx controller or a load balancer in place to handle the process. I think the last question is, what resources are required to make microservices in .NET? Rishi, will take this one.
Okay, amazing. I would highly encourage you to go just search this term microservices.net, and I have gone through. There is very well documented wiki or blog from Microsoft which talks about. Okay, so when you say .NET, I'll also say I encourage you that because you are in .NET, you go to Azure. So use Azure specific app services to run your microservice. So that blog or that wiki from Microsoft should be enough to give you all the required resources to make your microservice like a hello world microservice. Go it running like a front and back end, make it running in .NET or Azure specific architecture. And this is my recommendation. If you follow that particular blog, or this is one thing. Okay, I just want to add here for everybody who is part of this conversation, make a habit of reading documentation. Okay, when you search something on internet, if you have 2 links, one is a link of personal blog and another is documentation, official documentation, go to official documentation first. That will help you a lot in your career. So take help of that, and that shall suffice.
Great. It's a great concluding advice, Rishi. I think, Rashmi, we can conclude this session. We are done with all the questions.
Yes, it has been a long discussion and we are way beyond time. All right, a lot of questions have been answered. I see some more comments in LinkedIn chat as well, but let's take it some other time, right? Thank you so much, Rishabh, for hosting this panel discussion beautifully and answering all the questions. Thank you so much, Rishi, once again for taking out the time for the discussion and answering all the questions. I hope you guys also enjoyed the questions that were asked by the attendees, right? And all of you folks who are listening to us live on LinkedIn, thank you so much for tuning in and staying till the end. And the ones who are in Zoom as well, thank you so much, guys, for joining in. I hope you learned something new from today's webinar. And if you did, would love to see some of your learnings from today's session. Tell them what did you learn. Go to LinkedIn, post about it. Tag Rishabh also, Rishi also, and Rekro also. And we would love to see some of your posts. All right. On that note, let's wrap this up. Thank you so much, Rishabh and Rishi, once again for joining us.
Thank you, sir. Thank you, Rashmi. Thank you, Rishi.
And have a good weekend, guys.
Thank you. Yeah.
Bye. Thank you.